for the Grid IQ Insight project for GE Digital Energy.
For a Canadian utility company, outage management and service restoration are among its top annual expenses, exceeding $100 million per year. With advanced processing, analytics, and visualization of big data collected from the grid and multiple external sources, their command center is a lens on the world that allows people to interact in real time and more natural ways with information. Using innovative software, operators can manipulate intelligent information, using hand gestures to call out menus or to view data on outages within a region. They can easily rotate, pan, and zoom for better viewing angles, and can pull up the Vegetation Wizard to inspect various areas for outage predictions. This system lets people discover insights in the data that were previously beyond their grasp to be more predictive and more productive.
The system is a multimodal, multi-user, multi-display, cross-device collaboration platform for collective sense-making, interactive data visualization, manipulation, and design. The system has a highly parallelized hardware and software architecture with support for natural inputs such as touch, gesture, and voice through devices such as Kinect, iPad, iPhones, touchscreens, eye trackers, infrared, and possibly electromagnetic tracking systems, allowing for collaborative space that optimizes efficiency in visualizing, analyzing, and ultimately designing and servicing the products of the future. The current focus of Grid IQ Insight is predictive outage analytics. We are working on building an outage prediction model based on the data we collected from multiple independent sources such as historical outage data, weather features, vegetation distribution, etc. The benefit for the utility companies is to reduce the preventable outages, such as vegetation-caused outages, by monitoring network and taking suggestions from analytics results for opportunities to perform preemptive actions. The user can interact with the system through gestures. An ergonomic radial menu designed by our group can be activated seamlessly by reaching behind him, building by that fact a mental model that immerses the user in the virtual data. Once interacting with the menu, it can be discarded by throwing it behind his back. The user can also navigate the data through simple hand motions. The map can be moved to the left, right, top, and bottom. We built a metaphor we call the ether. The user imagines that there is a moving ether in front of him, similar to an invisible wall of ether that is sensitive to motion. Once the hand enters in the space of the ether, a motion is triggered that ties the virtual environment to the hand. The user can also zoom in and out of the map through touch gesture on the iPad, as one would naturally do on a mobile device. The same map can also be moved in any direction using touch gestures. Now we are going to demonstrate the prototype that we built for Hydro-Québec, a Canadian utility company. Now, what we are seeing is the Quebec region in Canada with a subset of color-coded feeders. The long lines jutting out of the map represent outliers in the given data. The feeders can be turned on and off through the mobile device. The map can also be turned on and off. You can see the vegetation data visualized as a dynamic 3D heat map showing an index of reflection of the vegetation foliage density throughout 2005 and 2006. The red color represents high values, the blue low values, and the height is linearly proportional to the density. The vegetation data can be visualized either as a dynamic 3D heat surface or just the foliage, and the visualization modes can be switched using the touch interface. Geographic data used for prediction can be represented as a semi-transparent heat surface overlaid on the terrain. This data will be used to assess outage prediction. We continue to improve and expand the capabilities of this system. We have also started using this system in other GE businesses such as healthcare, MR and CT, transportation, aviation, etc. We improved the system to include a co-located interactive real-time collaboration and telepresence setting seen on the 3 left displays to the left of the main 6 screens. We can think of these as being in another country or building, say in Neskiuna. All the gestures and visualizations happening on the main 6 screen, say in Saint Ramon, are duplicated on the triptych to their left in Neskiuna. The parallel nature of the hardware and software architecture allows such virtual teleport of millions of triangles in a seamless way. Two groups of scientists can collaborate in this manner, having hands on the data at the same time in the same virtual space. We added also in the virtual Neskiuna co-location a multi-touch screen to handle interactions with multi-dimensional data. While seeing what the San Ramon operators are visualizing on the GIS information, the Neskiuna scientists can analyze the multi-dimensional data they have and push it back to the San Ramon location. Here we see an interactive filter being applied to the probability variable to look at the correlation of probability of electrical outage with variables such as wind, vegetation, storms, and electrical outage history. The same system was also extended to be used in medical intervention use cases, allowing a doctor to interact with a 3D model of CT scanned images without touching any device. This is critical during intervention since the doctor cannot touch any non-sterilized device. Currently, the doctor verbally asks someone to rotate to the left or right, up and down a 3D model. You can imagine how tedious it is to communicate verbally a 3D pose. In addition of navigating the 3D model, our software can also assign interactively different levels of transparency to remove occluding organs and focus on malignant areas of interest. This is done in a touchless way. We finally use the system to visualize transportation-related use cases. Here we see the oil temperature of locomotives throughout the United States when a fault happened on board of the locomotive. We continue to add cutting-edge technologies here. Here we look at the Leap Motion device released last month in January 2013. This is an infrared-based tracking device that can track fingers to 1/100th of a millimeter for touchless, precise motions.